Good day guys, this is your data engineer. We are continuing today with graphs and motion. So let's start with today's lesson. For each of the following velocity time graph, find the first question is the total displacement at the end of the motion. The second part of the question, the magnitude of the acceleration over each section of the graph. Draw the acceleration time graph. Okay, let's get right onto it. Okay, for the first graph, 11.1, we first have to calculate the displacement. Remember, if you are given the velocity time graph and you have to work out the displacement, that means you need to work out the area under the velocity time graph. Whenever you are given the velocity time graph and you have to work out the acceleration, it means you need to deal with the slope under the velocity time graph. So that will be our approach. So let's start with 11.1. Let's work out the displacement. So the area under this velocity time graph, this will be the area. On this area we have the base of 16 seconds and the height is 10 meters per second. So we'll say here the first part of the question, which is total displacement, is change in x, is equal to, since it's a rectangle, base times height. Base is 16, height is 10. That means the displacement is 160 meters in the positive direction. Okay, so the second part of the question, you have to calculate the acceleration. That means you need the coordinates to work out the slope. You have 16 here, and then you have a 10 there, and then here the coordinate is 0 and 10. Acceleration is v2 minus v1 divided by t2 minus t1. So that's the formula. Then v2 is 10 and v1 is also 10, so you'll have 10 minus 10 divided by 16 minus 0. So it will give us 0 divided by 16, which is 0 meters per square second. Okay, so remember, the second question requires us to plot the acceleration time graph. So here let's write acceleration, and here you'll have the time in seconds. So the time scale remains the same, but since we calculated the acceleration of 0, so we'll just write acceleration is going to be 0 per square second. That's the first question. Now let's go to the second question. We're going to do the same exercise. The displacement is the area under this graph, which we see that it's a triangle. So we'll have half base times height. The base is 4 and the height is 12, right? 12 meters per second. So here you'll have half base, which is 4, height is 12. So you'll have half times 4 times 12 is 24 meters in the positive direction. And then the second part of the question is acceleration. The coordinate here you'll have 4 and 12. The coordinate of the origin is 0 and 0. So acceleration is v2 minus v1 divided by t2 minus t1, which will be v2 is 12 minus 0. So here you have 12 minus 0. Then t2 is 4 minus 0. So basically we'll have 12 over 4, which is 3 meter per square second in the positive direction. So let's plot the acceleration on the graph. So a 3 will be there, so acceleration will be a straight line, a straight constant line. So that's it for question 11.2. Then 11.3, same exercise. Displacement is the area under this graph. Just you have to recognize that this is a trapezium, right? So you know that the equation of the trapezium, let me write here. If you have a trapezium, the side there on top is A, the one at the bottom is B, and then they're separated by the length of H. That means the area you'll say is half the side that separates the two sides H and the sum of A and B. So that's the area of the trapezium. We're going to apply the same principle. Here, our A will be 10 and our B will be 16 there. And then our H will be 3. So I'll have half. H is 3. Then A is 10. B is 16. So I'll have half times 3 times 26. So that one we can calculate as 39 meters in the positive direction. Then when it comes to the acceleration, we're dealing with the slope, so the coordinate here is 3. Okay, let me just choose a color so that you don't confuse ourselves. So here we have 3. The coordinate here is 3 and 16. The coordinate here is 0 and 10. So let's work out the acceleration. It's going to be v2 minus v1 divided by t2 minus t1. v2 is 16 minus 10. t2 3 minus 0. So 16 minus 10 is 6 over 3, which is 2 meters per square second in the positive direction. So let's plot that on the acceleration time graph. So you'll have a 2 there, which is going to be a constant line until time is 3 seconds. So that's it for 11.3. Let's go to the next question, 11.4. Okay, let's write out the displacement formula. Remember, this is also a trapezium. In this case, our A is 50 minus 20, which is 30, right? And then our B is 0 to 60, right? So our B will be 60. And then our height is 30. So let's write half HA plus B. Since we're dealing with the trapezium, that means change in X will be H, which is 30. A is 30 as well. B is 60. So you'll have here, you can just divide 30 divided by 2 is 15. 30 plus 60 is 90. So the answer, 15 times 90 is 1350 meters in the positive direction. Now let's deal with the acceleration. So the acceleration will be quite different now, since we'll have a coordinate here, which is, okay, let's change the color again. Let's change the color to purple. Okay, here the coordinate will be 20 and 30, 50 and 30. Here is 60 and 0, and here is 0, 0 at the origin. So let's calculate the acceleration on the first part of the triangle. We have 30, right? 30 minus 0, and then divide by 20 minus 0. The answer of the acceleration is going to be 1.5 meters per square second in the positive direction. That's the first acceleration. Then the second one, 30 minus 30, which you can recognize that it's going to be 0. So eventually 30 minus 30 is 0. 50 minus 20 is 30, so the answer is 0. Okay, and finally the last acceleration, we will say 30 minus 0 divide by 50 minus 60 will give us 30 divided by minus 10, which is going to be minus 3 in the opposite, or you can just say 3 in the opposite direction, negative direction. Okay, so to plot that on the acceleration, time axis, here you'll have 20 seconds, 50, and then 60. So the first acceleration, let's choose now again. Let's go back to blue. The first acceleration was 1.5, so you can just choose a scale of 1.5 to 3. Also here you'll have 1.5 and then 3. So let's plot 1.5 on the first 20 seconds, and then between 20 and 50 the acceleration is 0, so just plot a 0 there. And then between 50 and 60 seconds the acceleration is minus 3, which is just here, since minus 3 is there, so this is minus 3 here. So that is it. Let's just hatch the graph so that you see this is the acceleration time graph. So we've come to the end of our today's lesson. If you liked today's lesson, please hit the like button and subscribe, and stay tuned on the next lesson. Cheers.